The last piece to Chapter 8, Part 2, and the last section that we are going to cover this trimester is on solving radical equations. So now it's just a matter of getting down to that x. One of the things that I noticed a lot with the solving rational equations part in Part 1 was that some of you didn't solve all the way down. We want to get x equal by itself. So our first step is going to be that piece of getting rid of any plus or minus, addition or subtraction outside that radical. In our particular case here of a, we don't have any of that, so we can move on to step 2, which is getting rid of any multiplication or division outside of the radical sign. In our case, we have this times 2 out front, so I'm going to divide both sides by 2, which will get that 2 gone, leaving me with the square root of x plus 5, and that is equal to 8 divided by 2, which is 4. Our next step is going to be to get rid of that radical sign by either squaring or cubing or whatever the root is determined by that index. Because this x plus 5 is being square rooted, in order to get rid of that, we're going to take that whole thing and we're going to square it on both sides. Remember that if you square a radical, what is inside that radical is what becomes what's left. So we're left with x plus 5, because if we square rooted x plus 5 and x plus 5, we get all this fun stuff in between, and therefore it becomes x plus 5. And 4 squared is 16. Now the next piece is subtracting 5, because our step 4 is going to be simply to solve the remaining equation. And when we do that, we get x is equal to 11. Now, one of the things that we need to make sure we're doing, just like we did with rational equations, is going to be to check your solution. And this is very important, because if you don't check your solution, you might get something that actually doesn't work. So if I'm not necessarily going to require you to write out your check, we're going to write them out in this video. However, if you can do it mentally, that is perfectly okay. Our check states that if it works, we should have 2 times the radical of 11 plus 5 should equal 8. Well, 2 times the radical, 11 plus 5 is 16. So square root of 16 is 4, so 2 times 4 should equal 8. Yes, that in fact does work. We know that our equation checks out. Moving on to example B. In example B, the first thing that we're going to do is divide by 3 on both sides. That cancels here, giving us the square root of 2x minus 1 is equal to 6 divided by 3, which is 2. Then we are going to square both sides, giving me 2x minus 1 equal to 2 squared, which is 4. Then I add 1 to both sides, giving me 2x equal to 5. And then I divide by 2 on both sides, giving me x is equal to 5 halves, or 2 1/2. If I go ahead and check this, I see that we should have 3 times the square root of 2 times 5 halves minus 1 should equal 6. Well, 2 times 5 halves leaves me with 5, so we have 3 times the square root of 5 minus 1 equal to 6. 3 times the square root of 4 equal to 6. Square root of 4 is 2. 3 times 2 should equal 6, which in fact it does. And some of you might be wondering why I go all the way to 6 equals 6. I'm just setting it up to prove that what I get is what I should. In example C, we have here a cube root. We have an index here, so to undo cube rooting, we're going to cube both sides, because we don't have anything outside of the radical to get rid of. When I do that, cube root of something, cubing something that's a cube root is going to give us, once again, what's inside. So I should have x minus 5 equals 7 minus x. Then I want to get my x's on the same side, so I'm going to add x to both sides, giving me 2x minus 5 equal to 7. Add 5 to both sides, which gives me 2x equal to 12. Divide by 2 on both sides, giving me x is equal to 6. If I go ahead and check this, I get that cube root of 6 minus 5 should equal the cube root of 7 minus 6. Well, 6 minus 5 is 1, cube root of 1, 7 minus 6 is 1, and I'm at the point where those are already equal to each other. I don't need to go any further. Moving on to another example, example D. Here, I first need to start off by subtracting 3 from both sides. That leaves me with the square root of x minus 1 equals 2x minus 3. I want to square both sides, and that gives me on the left-hand side x minus 1. On the right-hand side, I need to FOIL out 2x minus 3 times 2x minus 3. That gives me 4x squared minus 6x, which is minus 12x, plus 9. I want to subtract x and add 1 on both sides. These cancel, giving me 0 is equal to 4x squared minus 13x plus 10. Because of this 4 in front of the x squared, I need to use the AC method. I need two numbers that multiply to 4 times 10, which is 40, add to negative 13. Because I need to add to a negative, both my numbers need to be negative. Negative 8 times negative 5 does give me negative 13. So this means that I now have 4x squared minus 8x, which I'm going to group together, and negative 5x plus 10, which is going to be grouped together. When I go through, I get here, I'm going to pull out a 4x, which leaves me with x minus 2, and I'll pull out a negative 5, which leaves me with x minus 2. And so when I do this, I have that 0 equals 4x minus 5 times x minus 2. According to this, that means that x should either equal, if I have this equal to 0, I add 5 divided by 4, I get 5/4. If I have this, I add 2 to both sides to get 2. Now I need to check both of these. So if I go and do my check, I first start with 5/4. Going back up to the top equation, I should have the square root of 5/4 minus 1 plus 3 should equal 2 times 5/4. When I go and multiply this out, 5/4 minus 1, that's 1 and 1/4 minus 1. I get the square root of 1/4 plus 3. 2 times 5/4, this goes down to 2. I should have 5/2. Square root of 1/4 is 1/2, and 5/2 is 2 1/2, just for reference. 3 plus a half is 3 1/2. That does not equal 2 1/2. That means that 5/4 is not one of my solutions. However, if I then go and check my 2, I should have the square root of 2 minus 1 plus 3 should equal 2. 2 minus 1 is 1, plus 3 should equal 2. We get 2, no, square root of 1 is 1, 1 plus 3, oh, I'm sorry, this should be 2x, so this should be 2 times 2. And so 1 plus 3 should equal 4. 4 does, in fact, equal 4. So 2 is my solution for this, whereas 5/4 is not. If we go on to example E, we have here a 4 on the outside. However, if I divide by 4, I'm going to make it really messy. So instead, I'm going to right off the bat square this. And when I do that, I get x plus 2. And that equals 4 squared is 16. Square root of x squared is x. We can subtract x from both sides. That gives me 2 is equal to 15x. Divide by 15. And I get x is equal to 2/15. Now to check this, My answer of what should be 2/15, I want to go ahead and check this. When I check this, I should have that the square root of 2/15 plus 2 should equal 4 times the square root of 2/15. Now I know none of that is really pretty, but what I want to do is I want to have, this is over 1, I want to get a common denominator. So if I turn this into 15ths, multiplied by 15, 2 times 15 gives me 30. So if I add these, I get the square root of 32 over 15. Now, if I think about this, this is over 1, and I can break this up. So this would be 4 times the square root of 2 over 1 times the square root of 15. And I know some of you might not be following that. I'm thinking in terms of breaking this piece up to make it easier to work with. Now, square root of 32 over square root of 15, we can do break that up. And if I do that, square root of 32 is square root of 16 times 2, still over square root of 15. Yes, I know you're thinking rationalizing. We're not going to rationalize. Square root of 16 is 4. And so we got 4 square root of 2 over square root of 15. Now before we say, hey, now I need to simplify, I see that gives me the same answer. So this checks out. Therefore, 2/15 is a correct answer. Now, our final problem. We have 2x plus 1 to the 1/3 power equal to 2. One of the things that we have been working with is that when we have the 1/3 power, that denominator of that fraction is our index. So this is like saying the cube root of 2x plus 1. Because if you think about it, square root is to the 1/2 power. That's why if you have x squared and you take it to the 1/2 power, which is square rooting, 2 times 1/2 is 1. That's why the square root of x squared is equal to x. So this is equal to 2. So to get rid of that cube root, I'm going to cube, which gives me 2x plus 1 equal to 8. So if I subtract 1, I get 2x equal to 7. Divide by 2, I get x is equal to 7 halves. To check this, to make sure that that works, I have 7 halves times 2 plus 1, that should be to the 1/3 power cube rooted, should give me 2. Well, this is over 1, these 2's cancel, and I get 7 plus 1 to the 1/3 power equal to 2. 7 plus 1 is 8. 8 to the 1/3 power is 8 cube rooted. Cube root of 8 is 2. So x equals 7 halves is my answer. What you need to do now is go ahead and give these 4 U-Try problems a shot. Bring your questions with you to class tomorrow, and don't forget to write your summary.